Hi, my name's David Capetti, and welcome to DCO Graphics Studio. This video is perfect for students, architects, engineers, or any designer that wants to learn how Grasshopper and parametric design works. All of the steps in this video are pretty straightforward, but if you have any questions, make sure you let me know in the comments below.
Hi everyone, in this video I'll be going over this Grasshopper script that allows you to create this type of watertight solid vase shape that we can adjust the height parameters, we can adjust the offset, we can do it to the inside, we can do it to the outside. We can play around also with the top offset, if we want it to be to the inside or outside. We can play around with the base offset, the thickness of the wall, and ultimately come down here and put some patterns on it where we have a little bit of fun there. And then here we have the final watertight solid, we have the top lip, and we have the base. And so that's what I will be showing today. And if I show you the object, so let's go to zoom extents, you'll see that these are the three examples of the things that we'll be creating today. And so I'll go here to rendered view, and you'll see we'll create some cool 3D printable watertight solid structures. Okay, so I have here a brand new project, and I'm going to go here to units, and I'll show you. I'll be using millimeters, and I have here the under decimals here under distance display, and that's because I'm going to be 3D printing it, and that's the units that the 3D printer uses. So let's go here, and we have a new project, and let's go ahead and start with the circle. And this is going to be our base geometry. So I want it to be a diameter. And so if I go here and I go to 100 millimeters to be the radius, it's actually 200 millimeters. So if I want it to be the diameter, I have to do a division of 2. So I do divided by 2, and that gives me a component that already has a division with BS2. So let's go ahead and plug in 100 divided by 2, and that will give us 50, and then that could be our diameter radius for the overall outside of the base. And so that's going to be our base geometry that we're going to be moving up and then offsetting out. So let's go ahead and get that done right now. Let's take this and move it. So double click here, go to move, and this is going to give us a move component that's going to ask us for geometry and the motion. Let's plug in the circle as the geometry, and it's going to move it up a default of 10 automatically, but we want to be able to adjust that ourselves. So let's go to unit Z, double click, and that's going to give us a motion in the vector Z direction, and it'll allow us to plug in a slider here that we can slide down, hold down Alt, and make a copy, and that way you can use a slider to adjust the Z vector height for this curve. And so let's go here and put it to, let's say 30, and that's going to be our second curve. Now we're going to have to move one up again, that way we can go ahead and create like a wavy type of form on the outside. So let's move this circle again up, and then if we want it to be a consistent amount that we move up, we can just plug in this vector here, and there we have one curve here in the middle and one curve here at the top with the base one there. And we can go ahead and already loft this these curves, so we can plug this in here, we can plug that second one there, and we can plug the third one here, and we can see that everything is working out. But it's still kind of boring because all of the circles are the exact same size. So to vary the size of these curves, we're going to want to offset them. So let's go ahead and delete that loft because we don't need it right now. And let's go ahead and offset this curve, the middle curve, out, let's say a distance of 15 millimeters. And so now we have the ability to kind of move out, but we don't have the ability to move in. So let's actually delete this slider, and let me show you how to create a slider with a range of a minimum and maximum that you want. So let's go to minus 15 dot 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 15. That'll give us the minimum of negative 15, and it'll give a maximum of 15. And then if I hit enter here, you'll see the slider of minus 15 to 15. So if we put it at 0, we are actually at the exact same spot. Actually, this is at 1. So if we are at 0, the same spot, we can move out and we can move in. And we want to do the exact same, have the same ability with the bottom one. So let's go ahead and drag it and hold Alt. And that way you can make a quick copy. And we can do the same thing with the top one. Now, as you can see, we have two curves here being displayed. So let's go ahead and select those two and go ahead and do a spacebar and unpreview to hide everything. And so now we have the top curve and the middle curve and then the base curve. Now, as you can see, the top one here is being here on the script. It's actually the one that's down here. So we may want to switch things around. That way, it's a little bit makes more sense that this curve that is at the top, and this one that's at the bottom is in the middle. And then we have this is the base. So let's go ahead and loft together these curves and see what kind of effect we get. So let's start with our base geometry. Let's go ahead with our offsetted curve. Right click here and go to flatten. Oh, see, I did that wrong. That goes all the way to the top one. So actually undo that one. And let's plug in the next one, the middle one. And then we're going to plug in the top one. And there we have our lofted curve that we can increase here the height. We can change how wide it is. And they're all tied to this base one. So we're able to play around with the form. So this is the middle. We're able to kind of create this type of, cups that go like this or like that. And so it all depends on whatever it is that you are trying to do. But this gives us the flexibility to kind of play around with the base form. And then from here on out, we can actually go ahead and subdivide this using whatever type of geometry to kind of create a more even dynamic type of design. So that's something that that I'll be showing you later on today. Okay, so I've gone ahead and kind of cleaned everything up, and I actually put something called a panel. So double click and go to panel, and that's what I use to create these little text box where you can write the description of what the slider is. So here I put the base circle size. I guess we can go here, size. And these panels are useful so you can kind of organize your information. You can write more information here, and they're also bright, so you're able to know and zoom into which sliders are actually the ones that need to change. And so from here, we're going to move on to actually create and make this into a solid. And so let me show you the steps to get that done. So to give it a specific thickness, let's say we wanted a 4mm thick wall, we can actually just offset all of these curves that we had originally created. We can offset them by 4mm and then do the same command and create another shell on the inside. So let's go ahead and plug in that circle and see we offset out, but we actually want to offset in. So let's go to a negative here, double click, go to negative, and then let's bring a slider of 4. So double click, go to 4, and it'll give you a slider of 4. And now we can plug in that negative to that distance and see that we have a 4mm offset to the inside. We want to do that same thing to all the other ones. So let's go ahead and plug in this curve, holding down Shift to add another curve. So let's go ahead and plug that in. We see that it also worked. And let's do the same thing with the top curve. And there we have all of these curves that made that surface offset in by 4mm. So let's actually go ahead and loft together all of those curves once again, and it's just going to loft the first one, but if you go ahead and flatten it, it'll loft in the exact same way that it lofted the inside one. So now it's just a matter of kind of putting these two curves together and putting these two curves together, and we will have a perfectly watertight solid made here in Grasshopper. Okay, so now that we have these two shells, let's go ahead and select those two, spacebar and unpreview, and we'll see that we have these two curves, and we also have these two curves, but these curves on the inside are actually tied in all inside of here. So we're gonna have to pick this one and one of these, the top one, and then this one, and with this one of the bottom ones. So to pick an item out of these, we're gonna go to list item and plug in those curves, because we have 3 curves here, and we're gonna pick one of those curves, and it's gonna give us here the top and the bottom, but we just want one. So let's actually go here to flatten, and it'll give us the bottom one. So we can use this bottom one, but we also want the top one. So we want to slide up, hold Alt, make a copy, and then here right click under index, go to integer, and you can plug in yourself here. If you go to integer, you can do 1, commit, and that way you'll see that, oh, 1 is actually the second one. So we actually want the integer of 2. And you could have, so we have the top one that we extracted from here, and we also have the bottom one. Now, if you don't want to use right click and use index, you can always go here and go to number slider of 2, and then plug that right into here. If it's a little bit weird or intimidating to kind of click here and try to find the integer, so you could always use a slider. And we have the top, bottom, and now we have a command called boundary surface, which will actually create a plane right in between these two. So once you bring in the boundary surfaces, we'll plug in the bottom one of the curves, and then the base circle. And holding shift, you can add both of them, and there we have that base surface. And we want to do the exact same thing with the top surface. So let's go to boundary surfaces here, and let's click on that top curve, plug it in there, and then holding down shift, we're gonna do the other one. Now if it doesn't work, you want to right click here and go to flatten, and we should always just flatten this one regardless, because it might mess up later on, but right now it's working pretty good. And we have the 2 top and bottom lids, and then we have, if we do a spacebar and we preview, we have the outside. So all we have to do is put it together, and we can use a component called join brep. So brep join, and we can plug in this loft. We can plug in the bottom surface, top surface, and then the inside loft. And then we'll go here to flatten to make sure that everything is kind of in one solid list, and we can select all of this stuff that we did before, hide the preview, and there we have a closed brep. And this is, you're able to adjust the mid offset to, make it a little bit bulgier or less. And then here at the top, we can also come in a little bit or make it a little bit wider. It all depends on what parameters we want to, use for our 3D print. So let's move on to the next step, which is going to be for creating a base here. And there's many different ways that we could create a base. So I'll be showing you, a couple of examples that will give you a nice result for something like this. Okay, so now that we have this solid, let's go ahead and create the base. And the base is actually pretty straightforward because we already have our base outside circle, and it's just a matter of basically extruding it down. That way we can have something for it to sit on. And let's see, let's go ahead and take that circle, and let's go to a double click and go to boundary surface, and take that circle, plug it into the boundary surface, and you should have a surface here at the bottom. Now this surface we can extrude. So let's plug that in, and it's going to extrude up. So let's actually go Z, and let's go to a negative. Because we actually want to extrude down. So we'll plug that in here, plug this in here, and it's going to ask us for a distance. So if we have the wall thickness as 4 millimeters, then we'll do the base also at 4 millimeters. So without needing to actually use a new slider, we can just use the wall thickness slider as the base slider. We'll plug that right into there. But if we wanted to, we could always come in and take one of these sliders, copy it over, and then make it its own unique slider with a bigger base. So that really depends on, the final design that you would want. So you could either use and tie it all together using, a single slider, or you can have an independent one here, because sometimes you want the wall thickness, let's say, to be 2 millimeters, and that's a little bit too thin for a base. So then we can come here and just do a 3 millimeter base. It all depends on what you want in the end, but those are some options. Now we just have the base, but it would also be nice to create a lip here to give it more of a, not just the base, but also a kind of finish up here. So let's actually go to one of these. So I'm going to take that whole solid, do a spacebar and hide, and I previewed the bottom one, but I don't want to preview that one. I want to preview the top one. And I want to extrude this up a certain amount. And we already kind of did that here. So let's go ahead and take this, copy it over, slide over and holding Alt. And then let's take that surface, put it there. But instead of negative, we'll actually just use a regular slider. And this is going to be our top lip. So then we can write that here. And then here we'll click on, or we'll write base, and that's going to be the thickness for the base. So let's go ahead and actually bring back this one. Right click and preview. Oh, actually not that one. We'll actually have to bring this one, the B rep, and we can hide this surface. So there we have a top lip here that we can make a little bit bigger for the top, and we have a base where we can adjust the base here. Now let's not forget that we could always come here and adjust how small it's going to be and how big it's going to be, and also the height. So this could be a little bit of a shorter, kind of stoutier bowl, and then here we can actually come in and out. So it really gives us a lot of versatility and a lot of play. And that's what's cool about this program, is that all of our work is kind of contained here, and so we can always go back and adjust anything. We can adjust the thickness. We can play around with so many parameters, so we could always come back and adjust it to whatever application that we're trying to do. So let's go ahead and take this solid geometry of BREP, and let's actually put a pattern all the way around it. That way we can, make it a little bit more fun and not just a solid shape. So that's what we're going to be doing right now. Okay, so before we do the pattern, I just want to show you. So if we take this one, which is the body, the top lip, and the base, and we do a space bar and then here to bake. Let's go ahead and hide this for now and come back. We'll come back to it and I'll show you. So we have this solid, but these are all separate solids. So we could always come here and do a Boolean union, BU for Boolean union, and now we have this as a perfect solid. But that's not something we want to do right away inside a Grasshopper. So I'm going to delete that and bring this back. And that's because it'll take a lot of computational effort for it to put it all together. And then at the same time, once we start putting the pattern on the outside, it'll just get so heavy that it might even crash the computer. So let's go ahead and take it easy and not put all of this together yet. We might be able to do that later on down the road, but for now, we'll just be keeping it separate, and now we'll be kind of creating that geometry right on top of this base surface that's going to be the outside surface. So we could even go ahead and hide all of this stuff, do a space bar, do a space bar here, and hide the preview. And we'll bring this back for our, let's also hide this bottom one. We'll just have this surface, which we're going to start, extracting some geometry from and creating the pattern for the bowl. Okay, so from here we can go ahead and bring in a component called isotrim. And isotrim is going to take, it's going to take a surface like this one, and it's going to break it down into a number of subdivisions. So as you can see here, it'll kind of break that surface and break it down. But we also need another component called divide domain squared. So let's also bring that in. So divide domain squared. And we want to plug in that surface right into that domain and these segments into the domain. And here we have a U and V of 10. So let's bring in a few sliders here. Let's say a 5 and 5. So making one copy of the other, and then putting in the U and the V. And then let's see what gives us a nice, so we'll go 3 here, and we'll go to like 10 here. And so there we've subdivided that surface into all of these little subdivided segments. So it has 30, so 3 times 10 is 30 different subdivided surfaces there. So let's go ahead and hide the preview of this one. And with this geometry we can do so many things. The first one I'm going to do is show you how to extract some pipes out of this and then use that for the geometry. So let's actually go ahead and join together all of these subdivides into one solid, so I'll flatten it also, into one solid B-rep, but that has one open B-rep that has all of these edges still contained inside of it. And then let's go ahead and go to pipe, and let's plug in that B-rep right into the curves there, and it's not going to work. So let's go ahead and do a B-rep edges, and then plug that into the B-rep there. And there we have the outside edges and we have the inside edges. So for that, we can go ahead and do a pipe now. And we can do an outside and an inside one. So we have the naked, which are, if I'm not mistaken, the exterior ones. And we have the interior ones that are the ones that are on the inside. So let's go for a 0.5 millimeter for the inside ones. And let's do a 1.25 millimeter for the outside one, these outside ones. Now we can go ahead here and go to caps, round, and we can go ahead and select all of this stuff, hide it, and then we can bring back the watertight solid. So spacebar and preview. And now we have this kind of grid type of geometry that we have right on top of that, and we can bring back these other portions. Let's see, bring back the top lip and bring back the base, and see, if this is something that that looks nice to us. Now we can always come back here and say that's not enough subdivisions in one direction, so let's go to 15. I'm going to go to 13 here actually, and see, it adjusts that. We can also come here and say that's a little bit too small, we want it to be a little bit bigger. And actually one thing I'm noticing is that all of these curves are actually separate. So this is going to be making how many? 26 different ones. So we're actually going to want to join together these curves, the outside curves, and we want to make a copy and do the same thing to the inside curves. And we want to put those into there, and you want to plug these into there instead of the other ones. And this will give us a nice a nice continuous curve rather than a bunch of tiny individual cut up little segments. So here we have those curves that are turned into pipes, and we can use these sliders to kind of play around with that geometry. And so as you can see, if I were to join all of this together, it would take me a very long time to even play around with some of these sliders, because it'll make it really heavy. And so that's why I'm keeping them as separate things right now. But later on, we can use a component called union, solid union, and we can just take this, we can put it all together. And so that'll be towards the end. So at this point, I'm going to show you, if I take all of these, all of our kind of final geometries, and I do a space bar and then bake, let me give you an idea and show you. So I'm going to hide the preview of Grasshopper. And so here we have, this is our one of our results that we have for our geometry. And if we go here to render, we'll see that, you know, it gives us a nice cool geometry that is watertight and we can 3D print. But if you don't, you know, if you find this a little bit boring or you want to try something else, then let's go ahead and, you know, give you an idea of another way that you can create some cool patterns here. Okay, so what I'm going to do is, so I don't lose all the work that I did before, I'm going to take all of this stuff and do a spacebar and disable. And that way I have here just what I need. I have the base kind of geometry here that we had before, and we could even unpreview this one and bring back this one. And then I'm going to show you another way of creating like a cool pattern here using this base geometry, but we're going to do it right next to kind of the other pattern, just so you can see in contrast how much work it takes to do the one before rather than one that I'm going to do right now. Okay, so I brought all of these back, but I'm actually going to select them again, do a space bar and hide. And I'm just going to be working with this iso trimmed surface that we had before. And so what we want to do now is extrude these surfaces to a point. So we're going to want to extract the center point of this whole surface. So to do that, let's go to a item called evaluate surface. And evaluate surface will take this surface and evaluate it and create a point. But for it to work, let's right click here and go to reparameterize for it to kind of work correctly. And one of the sliders that you're going to want to use for creating a point, there's different ways you can create a point, but the easiest one is going to be an MD slider. And that's going to give you a coordinate kind of system here, and it's going to put it right in the center. So that's what we want. We want a point exactly in the middle at the 0.5, and we'll plug that right in, and we'll see that it actually gives us a point exactly in the center of all of these iso trimmed, you know, cells. So let's go ahead and take that point, and let's actually not just, because right now we have it exactly on there, we want to move it perpendicular to all of these construction planes. So let's go ahead and move, double click and move. You're going to move these points. In which direction? So in which direction? It's going to be in the amplitude. So we're going to be using a component called amplitude that's going to ask us for a vector. So our vector is going to be actually the frame. The frame is this construction plane. And so we want to go perpendicular to each one of these planes, not just in the X or in the Z direction or in the Y direction, because they'll all go in one direction. We want them to go relative to each one of these planes. And so we'll plug in all of those frames into the vector. We'll go to amplitude of 3. So we'll say we want this point to move perpendicular to each one of these planes 3 millimeters, and we'll plug into that motion. And there we have it moved, but it actually did that, and it did it to the inside. So if we wanted to go to the outside, let's go to negative here, and we'll see that if we plug in the vector there to a negative, we go to a negative there, it actually offset it to the outside. And the reason why I want to do that is because once We have this point. Now we can extrude this surface to that point and then give us a nice kind of studded type of look. So let's go ahead and extrude. We're going to extrude each and every one of these surfaces. So let's plug in those surfaces there. No, it's not extrude, sorry. It's going to be extrude to point. So we want all of these surfaces to be extruded to what point? It's going to be to this point. So we'll plug in this point to that point, and there we have extruded all of these surfaces that we had before. We have extruded it out and created kind of a pointed type of look that we can come here and adjust if we want it to stick out more or to stick out less or to not stick out at all. But for now, we'll leave it at 3, and we'll bring back our base geometry. And so there we have, we've created another type of geometry using the same base information, and it yielded a different result, but that I haven't booleaned all of this together because like I said, it'll be so heavy that it'll take a really long time, and that's something that we can do inside of Rhino afterwards. So we can select those, spacebar, and then bake, and then we can come here and see what we have. So let's go ahead and show, and we have now these 2 different 3D print ready solids that we can play around with. So that's just 2 different options of how you can subdivide a geometry using some of this information that we had already extracted initially. So this was the initial step, and this was the second one. And like I said, all of these parameters are still available for you to come and play with, and just if someone wants something with a particular number of subdivisions, you can come in and just pull a little slider and then have a brand new different design almost every single time. So I'm going to show you one last one to do a little bit more of like a polka dotted, or like some spheres here, and then just show you some other things that you might be able to do in Rhino to kind of switch them up even more. Okay, so let's do the same thing that we did on the last one. Let's go ahead and take this stuff. Let's take this one and let's do a disable the preview. That way we have just some of this stuff. So there we have those points that we moved out. But if we go before we moved out the points where we evaluated the surface, we see that we have all of these points there also. So why not just bring a sphere, put it right to those points, and let's say give it a radius of 3. And now we have more of a polka dotted type of design on it. Now we can, since this is a little bit not as heavy, we can actually just come here and make it a little bit more dense. So let's say 5. And we can always come here to 2 and make it a little bit smaller. And so that's another way that you can use some of this, geometry to create some watertight solids that look really interesting. And so let's go ahead and take this and let's put it all together with a Boolean union. So I'm going to go ahead and save my work, because at this point it's going to get really heavy. Let's do a solid union. And I'm going to go ahead and plug that into here. Plug in the spheres. Plug in the body of the container. Then we're going to plug in the top. And then ultimately bring the base right into it. And so if we go ahead and flatten it, it'll put it all together, and it will take a little bit of time, but at the end, we can go ahead and even hide everything here, do unpreview, and there we have this. That is a perfect watertight solid. So I'm going to go ahead and bake this and show you where we're at and the different results we got. So let's go ahead and show here. And so there we have the 3 different designs that we were able to create with basically the same script. And this is just the same form over and over, but we know that the form can change drastically depending on what parameters we use here. So hopefully you find that interesting and you learned something new in this tutorial. And please let me know if you have any questions or if you have ideas for future videos that you'd like to see. So thank you very much for watching, and I'll see you next time.
If you would like to help me out, make sure to leave a comment or a review letting me know what you thought of this course.
Thank you very much for watching, and I'll catch you on the next one.